Okay, so example 4 here, we're supposed to solve this equation, this logarithmic equation. And two places you want to get to in a logarithmic equation. Position 1 is log base b of y equals log base b of x. So one log equals the other log. There's nothing else going on in the problem. Bases must be the same base. The other position is log base b of y equals x. Just a single number. Either one of those two scenarios is workable in a logarithmic equation. As you can see, example 4 is already there. This is log base e of something equals log base e of something. So we're already in the position where we can do the next step. Okay? But again, one of those two scenarios. If you look at example 5, we're going to have multiple logs here, right? So we have to have a single log expression. There's a number on this side so that we can get this to say log of something equals 3. Here we have multiple log expressions equal to log expressions, so maybe I can make this into a single log expression equals that. But again, you want to get one log equals one log, or one log equals one number, one or the other. And this is, again, right where we want to be for this problem. Once you have one log and the other log are equal to each other with the same base, the arguments of those logarithms must be equal to each other. Okay? Just like exponential expressions, once you have the bases the same, the powers are the same. If you have logs with the same base, the arguments are the same. All right? And now logarithms are out of the problem. Now we're down to just an algebraic expression, equation that has whatever structure it has, we'll have to solve. Okay? As you can see, this happens to be a quadratic structure. So I'm going to start by making equals 0. So I'm going to move the 6x to the left. And now I'm in that quadratic structure equal to 0, which either I can see how to factor it immediately, or if I can't factor it very quickly, then I'm going to go the quadratic formula. For me personally, I'm seeing this as negative 8 times 2. Negative 8 times 2 makes negative 16. Negative 8 plus 2 makes negative 6. We do have a coefficient of 1 in front of x squared, so it's just the simple product sum fact that we need to figure out to factor it. So this one factoring would be pretty efficient. So I'd probably go that route on this one. So once I recognize the two numbers that do what they're supposed to do, I write my factored form, x minus 8 times x plus 2 is equal to 0. That's equivalent to the quadratic expression. And the reason we factor quadratic that's equal to 0 is we can use the zero product property, which states either factor 1, x minus 8 is equal to 0, or factor 2, x plus 2 is equal to 0. And that's going to lead us to answers. So if x minus 8 equals 0, I slide the 8 to the other side. When it x equals positive 8. If x plus 2 equals 0, I slide the 2 to the other side. It becomes negative. 0 minus 2 is negative 2. When you have a lead coefficient of 1, whatever answers these are, you always get the opposite signed answers. But I do recommend going through the technique of zero product property just to, again, keep that technique under control, because it's not always going to be the opposite numbers when you do factoring. Now the last thing with a logarithmic equation, you are required to test your answers. Okay, logarithms are very particular functions that have very particular rules, and the particular rule they have is that the argument, what we're taking the log of, this particular thing and this particular thing must both be positive numbers. If they are positive numbers, your answer is legitimate, allowed, and legal. If your arguments are negative, your answers must be thrown out. So we have two answers here, positive 8, negative 2. Negative answers don't immediately make them illegal. They have to make the expressions negative to be illegal. All right, so if I test positive 8 first, what's 8 squared? And 64 minus 16 is? 64 minus 16? 48. Even if you didn't know it was exactly 48, it's obviously positive, right? 64 minus something smaller than 64, so it's positive. We don't have to necessarily get the numerical value, we just have to verify positivity. So 64 minus 16 is positive, specifically positive 48. What's 6 times 8? 48, also positive, right? Again, the requirement is positivity. If they're both positive, you're in good shape. So 8's a legal answer. It will happen, it will work, all right? If we try negative 2, what's negative 2 squared? Positive form, 4 minus 16 is? Negative 12. So negative 2 creates a negative argument. Negative 2 times 6 is also negative 12. Either one being negative is no good, so we have to throw that answer out. So for particular logarithmic equations, no matter what the base is, the arguments must be positive with the answers you get. All right? If this answer was, well, let's see. Suppose we had some logarithmic equation. Let's just say this says log of 16. Let's just say that. I pretend it said that. And suppose I got the answer negative 5. Okay, it's the wrong answer, but pretend I got negative 5 as an answer. Negative 5 squared is positive 25. 25 minus 16 is positive 9. 16 is positive. That would have been a legal answer in that case. All right, so again, just because you see a negative number doesn't make it wrong. You have to verify that the values come out positive with your answers. All right, so make sure that every time you do a logarithmic equation, no matter what you start off with, that the arguments, what's highlighted in blue, are positive values based on your answers. If they are, the answer's good. If they aren't, the answer's bad. Toss it out.